Just a reminder, I want to remind everybody my pet peeve about the cell phones out. If you're looking at your crotch and smiling, I know your cell phone's out. I hope your cell phone's out. So in your book, they have all the theorems numbered all the way through. But one of the tricks that I've had, because you have to memorize the theorems in some way so you can use them as references, and they have to come to mind. So the important theorems, I name my theorems myself. So this is my name for this theorem. It's called the linear combo theorem under my name. But you can name your theorems as you're going along any way you want. You don't want to say, like somebody was asking, do I have to reference the page that it comes from? You know, 10 years from now, you're not going to remember the page, I hope, the page number from some book of one theorem. You're going to remember the important theorem. You're going to remember fundamental theorem of calculus. Those have names. So I name some of them that seem to be important that I keep using again and again. This one's important, so I named it linear combo theorem. In your book, it's theorem 4. So if I have two positive integers and I know that the GCD is D, then what I know is that I can write D as a linear combination of A and B. That's all that says. And it seems so innocent too. All of these things seem innocent when you're reading it and you're like, oh, what does that have to do with anything? It's actually pretty important. So this is a problem from the book. I just pulled one, so random one, so I can work one more with you. And then we'll go to the in-class assignment, second part, and we'll do a proof together in class. Getting used to this. Take out the no, that's the stuff between the if and the then. That comes out. Write down what it means. It means there exists an S and a T, blah, 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 blah. I get to my nuggets and I've got that. So I'm skipping some of the slowness now. We're seeing that over and over. The show part is the D squared divides AB. Show means that I can expand that out. That means I have to show that I have to come up with that X, so that AB is D squared X. I always try to rephrase it so it's very clear what I have to do. Now, if I have to show there exists something, that means I have to come up with it. So I might even rephrase that and say, I have to come up with this. That's my job. So those are my no nuggets up there, what I can use. And my show nuggets, that's what I have to come up with, that X. I have to come up with a formula for that X. And I don't know why I've never told my classes that before, but that's what you have to do. You have to come up with a formula for that X. Whenever they say there exists something, you have to come up with a formula for whatever they say that there exists. So where's my no? Scratch work. Well, my no has, where I have to end up, it has a D squared in it. And my no doesn't have any D squareds in it. So what could I do maybe to get it into play? How could it start up from the top green box and get a D square involved? Multiply them together? Let's try that. Maybe that's what I tried. Yep, that's what I tried. So I hit both sides with a B, which I'm going to actually sub in and get that D squared. And why did I do that? Well, they gave me two nuggets of information. If I put those two nuggets together somehow, I will end up getting the D squared to look more like what I have to prove. And it takes both of those pieces of information and uses it. So I could have multiplied both sides by a D of the first equation and then got a D squared. But this way I'm using everything I know right away to see if I can get it to streamline down to the end. And I'm done. Because I have to come up with a formula for the X. I'm supposed to, if you go back to the show, I was supposed to come up with AB equals D squared times a formula for something here. Now I got a formula for something here, S times T. It fell out of the note. Each step was logical, and I ended up right here. And now I can define X to be that ST. So as you're working through this, you're really like a detective. You're going in and putting down the piece that you know, and putting down what you have to show, and then just messing with it until you get to the end. So clean proof. Here's what it looks like when you write it up and turn it into Dr. Mukherjee. That's fine, actually. Why don't you do the work and into this class and turn it into Dr. Mukherjee? Don't say I said to do it. All right, for my hypothesis, I know D divides A and D divides B. Blah, 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 blah. Write down the words that go around it. That means there exists S and T such that you write down those equations. Then take the equation A equals DS and multiply both sides by B. See how I lead the reader? I just let them know what's going on. Now substitute on the left side of the equation B equals DT. So I make it clear. I didn't have any of this in my Scratch, like the parentheses and the nice stuff. Scratch work is fun. I'm just messing around with it. But now I'm trying to explain to a reader so they don't have to ask any questions. They can go, oh, this is what you did in number theory? This is so easy. That's all you're doing? By the associative property of multiplication, I can rotate those around, rotate things around. Since AB is expressed as a multiple of D squared, I don't even have to say I have a formula for the X, right? I can make it very clear to the reader. AB is a multiple of D squared. By definition, D squared divides AB.
You want us to write out, like now substitute, you can't just substitute.
Yeah, you have to explain it. Right, think of it like someone in here wrote a different proof. I could post it for one of the problems I did. And as I was looking through his proof, I had to ask him a question. What were you doing here? As soon as someone asks you that question, that's like, oh, there's the gap. I have to fill that gap in so my reader doesn't have to ask any questions. As far as I know, I think this is on YouTube. I hope Steve Peterson doesn't find me. As far as I know, out of all the time I've been doing math since 1987, I've been doing math since 1987, there's only been one guy that I know of that put too much detail. He cluttered up his proofs. Oh, maybe two. There was two. There was a lawyer who took our master's courses, and he wrote briefs for these tiny proofs, and it was awful. So, other than that, everybody put too little detail, opposite direction. Two people that I can think of. So err on the other side of putting more. Okay, so we're going to go to the in-class assignment now and do